I'm now standing directly atop the rocks forming the small nick point, this little zone of change in slope inside this nick zone. And what you can see as I pan back and forth is that these fractures are also determining the shape of this eroded section. So as I pan up a bit, you can see how these fractures actually, see if we can do this, connect down into the rock below. And in fact, wherever we have these blocks that can be quarried away, or sometimes we say plucked away from that wall, we're then creating these zones where we can have a vertical step. And so this fracture pattern in the granite is in fact dictating the size of the blocks that can be carried away, and therefore the morphology of the river. So it's part how much water is going down the river, how steep is it, how much stress can that water impart to the tops of those blocks to create lift forces and drag forces to rotate them and pull them up out of place. But part of it also is just how big are those blocks, right? Is that flow strong enough to have its lift forces and drag forces overcome the gravitational body forces that are holding that block in place? And so you can imagine, like in physics, right, a free body diagram on one of these blocks, and you say, all right, which one's going to win? And if the forces moving it win, then it can be broken off into the flow. And once it's broken off into the flow, well, it'll have a full free side. So let's walk a little bit downstream. So I'm walking on this deposit, which is created right now in the lee of this nick point right here. As I walk a little downstream, check out some of these boulders. They've been broken off of that face and transported down here, these pieces of granite. And what happens is that their upstream sides are now directly being impacted by the flow. So the drag force, once they're removed from that wall, becomes quite a lot higher. As a result, we might think that that threshold for initially removing blocks from the wall might be very important. And once those blocks are removed from the wall, they might relatively quickly make it downstream. Therefore, perhaps this is the reason that we see this wall, and instead of having a big pile of rocks next to it, we see the rocks all move away, because taking the rocks off the wall is really the rate limiting process in the erosion. And then after that, the transport of these protruding blocks, where we can have some lift on the surface and a lot more drag from all of the water that's just directly, impacting these upstream sides like this, just hitting it directly. That combination of drag forces and lift forces really makes these rocks preferentially move. All right, I'm now going to enter this valley where we're going to see further changes as we go through the next zone.